In section 5.2, we are introduced to the idea of summing up things, and we use sigma notation. It is the Greek letter sigma, which is right here. It looks kind of like a backwards S. Stands for sum. Now, there's different parts to it, and I've got that all right here. Let's make that a little bit bigger. All right, when you have the sum, down here, the index, k, that starts at k equals 1. So that tells you what number you're going to start with. Right here will be the function that you're talking about summing with. The index ends when k equals n. All right, so you have three parts there. And so here's some examples of what that might look like when you have them written out. In this one, k equals 1, you go to 5, and it's just k. So that's 1 plus 2 plus 3, etc. You add it up, and you get 15. In this one, the function's negative 1 to the k times k. And you go from 1 to 3. So you do it with 1, with 2, and 3. You add those up, and you get a sum. As you can see, these are ones that, you could do easily by hand. We will encounter some that you wouldn't want to do by hand, and there is a way to do it on the calculator. We're going to talk about then the Riemann sum. And what that is, like last section when we talked about the rectangles that we might draw in the area under a curve. And if we summed up the areas of those, we would get close to the actual area under the curve. And so Riemann sum is an approximation to that area by adding together the areas of a set of rectangles. So we're giving that a name, that process of what we're doing. There is a nice interactive video here that you could go to and see how that works. Let's see if I can make that happen for us right now. All right, this is what that interactive site brings you to, and this is they've graphed a curve here, 1 plus x to the 4th minus 3x squared. And you could put any curve you wanted in there, and you have an interval that you're going from negative 1 to 1.9. So you can see you've got that. And they use 29 rectangles. And let's see what we get. All right, let's try this with something different. Let's just do a plain old x squared. All right, so I put in x squared, and I said let's do that from negative 1 to 4. So that is the curve that's in red. And if I wanted to know the area underneath, and if I just use 8 rectangles, and it gives me an estimated area of 16.6797, actual is 21. Well, let's make that 15 rectangles. Okay, so we replotted it. Now we have 16 rectangles. Estimated area got to 18.9 something. We're getting closer. Let's make this 50. Not sure what's happening with that. There we go. And so as we can see, the estimated area went to 20.825. We're getting really, really close. So as we add rectangles, we're taking up more of the area, and we're filling in here, and we're getting close to the actual area. So that's the idea of taking a Riemann sum, which is summing up all those areas. Okay? All right, so let's go back and look at some problems. Oops. All right. First problem, write the sum without sigma notation and then evaluate it. So here's our function, 144k over k plus 7, and we only go from 1 to 2. So we fill in 1, and then we fill in 2. So that becomes 144 over 8 plus 288 over 9. Those actually divide evenly. You get 18 plus 32 equals 50. So 50 is going to go in that box, and you actually have this part allows you to choose answer D. Number 2, write this one. This one's really, really easy. We're going from 3 to 7, and we're putting in for k here. So we would have sine 3 pi plus sine 4 pi, etc., all the way to 7. And that line of items goes in this box because it says write out the sum. And then you evaluate the sum. And if you do that, if you're using your calculator, be sure that you're in radians. And you just, every one of those is equal to 0. So the total answer would be 0. On this one, it wants us to write it out in sigma notation. And without looking at these, it's a good idea to not look at your choices and go ahead and try. Use 1 as the lower limit and k for the index. Okay, so k equals 1. We're starting with that, and it looks like we're just adding 1 each time. So we're just using k. So if k is 1, and then k is 2 and 3, we're going to sum those up all the way to 29, and that's the way that would look. And so we're down here. All right. Now, these are talking about just some operations, and it's really not bad. You are given this one, okay, and then we're given this one. Okay, so we're saying this one, k equals 1 to n, the function equals 3. K equals 1 to n, this one equals 48. So if I have this one, 7 times that, and what do we've got? We've got a sub k, so we know we are here. 7 times that value, 7 times 3 is 21. On this one, we're looking at the bk, b sub k, and it's being divided by 48. So 48 divided by 48 is 1. All right. On this one, we are adding the 2. So 3 plus 48 is 51. On this one, we are subtracting the 2. 3 minus 48 is negative 45. This one, b sub k minus 5, a sub k. So 48 minus 5 times 3, that'd be 15. You'd get 33. All right. Now this one, we might not want to add up 11 items and have to figure that out. So this is where we're going to learn to do it on our calculator. We're going to use sum sequence. And here I have written out how you're going to do it. You're going to do second stat, choose math, then sum, follow this, and then we're going to put in the function, which is this, except you'll be using x, comma, always put the variable x, comma, the lower, the index, and then the upper, which is a n. Let's do that on here and get this one. Okay, so we'll do second stat, we'll over to math, and we'll choose sum, number 5. Then we'll do second stat, we'll go over to ops and choose number 5, which is sequence. Then we've got to put in the function. So it's negative 2k, so we'll put in negative 2x, comma, the variable x, comma, lower is 1, comma, and the upper is 11. We'll close those parentheses, and we will get negative 132. So in the way I've got this written, that equals didn't print. That's an equals, and we'll have negative 132 in that box. You do the same thing for this one, and I've written out, I've given you a screenshot of how that looks. You would get 445. All right. You can do the same thing here, and you can actually use your calculator even though you don't see an X. If you did, let's just do this last one here. All right. We've got the same thing. Second stat 5, second stat ops 5, and we're going to put the number 10, because that's our function, comma, x, comma, 3, comma, 264. Because you know 10 is a constant function. It is still a function. So we hit enter, and we get 2620. So you could do any of those on the calculator. All right. I think that'll get you this section. It's not bad. It's a real important idea. It's just a way to start getting into it.